Welcome to today's video. In today's video, we'll see how to carry out an ANOVA test using Excel Data Analysis ToolPak. As we have seen in our previous video on tests of significance, we will carry out an ANOVA test when we are comparing the variances across groups when we have more than two groups. So we'll find the data analysis at the right end of the data tab. So when we click, we get a list of tests. The first one is ANOVA single factor. So we will go for an ANOVA single factor or one-way ANOVA when we have one variable to compare across the groups. So for example, we may be doing an experiment where we will be studying the yield due to different varieties of seeds. Now when we compare across the groups, we can use one-way ANOVA. But simultaneously, suppose we are going to see the yield due to the different varieties of seeds as well as due to the different amount of rainfall received, then we can go for a two-way ANOVA. In today's demonstration, we will see ANOVA single factor. The first thing is we have to feed the input range. So we have filled it. And how have we arranged? We have arranged the groups in columns. So we have to check on columns. And the level of significance default is 0.05. We can get our result in a new worksheet. So you get the complete summary of the four groups, the count, the sum, the average, variance, etc. And we also get the ANOVA table, just like we manually prepare an ANOVA table, listing the source of variations between groups, within groups, degrees of freedom, and the computed F value. As we have seen earlier, we know that we have to compare with an F table when we are doing an ANOVA, and the F critical value is 3.49. Our calculated value is less than the table value, and the P value is also given. P is greater than 0.05. So there is no significant difference between the groups. We will see another example. So we have another set of data here. Again, we have arranged it in columns. We have the level of significance and we can get our result in a new worksheet. So we get the summary of the data and the ANOVA table. And in this example, we'll see that our calculated value of F is greater than the F critical value. And if you see the P value, you also know that P is not only less than 0.05, but it is also less than 0.01. So we know that the null hypothesis can be rejected and there is a significant difference between the groups, as we have discussed in our previous video on tests of significance. So today we saw two examples, one where we saw that there was no significant difference and the other where we have seen a significant difference. Now to find out between which of the groups we have significant differences, we have to do post hoc analysis. Like you have many tests, Duncan test, Dunnett's test, Tukey's test, etc. We have to use some software packages like SPSS to do those tests. Thank you.